In this video, we'll discuss a question from the 2006 free response questions, Form B. Number 4 says, the rate in calories per minute at which a person using an exercise machine burns calories is modeled by the function f. In the figure above, f of t equals, and they give us an equation here, which is true from 0 to 4. So that's for this piece of graph right here. And they also tell us that f is piecewise linear for values of t between 4 and 24. So we can safely assume that the rest of the pieces of this piecewise graph are made up of lines, as they seem to be from the picture we're shown. One thing that's important to note here is that the graph that we're given, f of t, is already a rate, right? They told us that this is the rate in calories per minute, so this graph is already a derivative. And that'll be useful to keep in mind later on. Part A says find f prime of 22, indicate units of measure. F prime of 22. So remember what that means. What we want to do is find the slope of the tangent line at x equals 22. Luckily, 22 would be some point in this interval where the graph of f is linear. It's a piece where the graph of f is linear. So to find the slope of the line that is tangent to the graph of f at that point, we would simply have to find the slope of the line itself, of this piece itself. Now, typically what we do here is count the slope. However, the scale of this graph will not allow us to do that, so we'll have to rely on our slope formula. Remember, our slope formula is y2 minus y1 over x2 minus x1. Or in this case, f of 24 minus f of 20 divided by 24 minus 20, which, if we look at the graph, they gave us those y values. The y value at 24 is 3, at 20 it's 15, so 3 minus 15 over 24 minus 20, which gives us negative 12 over 4, which is negative 3. And at this point we should feel confident with our answer, because if we notice, this piece of graph shows that f is decreasing there, or that the slope of the tangent line is negative there, and we did get a negative number. Now they also say indicate units of measure, so our final answer here would be, so we can write down negative 3. And here again, we have to remember that f is already a rate. F is already calories per minute, meaning that our answer for the derivative of f would be calories per minute per minute. And if we look at the axes, the way that they're labeled, the y-axis is labeled as calories per minute, and the t-axis is labeled as minutes. Okay, so our final answer here would be negative 3 calories per minute squared. Moving on to letter B. For the time interval from 0 to 24, at what time t is f increasing at its greatest rate? Show the reasoning that supports your answer. Okay, now this one's a little tricky because of the wording. First of all, they say at what time t is f increasing at its greatest rate. So we need to focus our eyes on the intervals in which f is increasing. And if we look at the graph, f is increasing in two places, here and here. Okay, so we have two intervals that we need to look at, which are from 0 to 4 and from 12 to 16. We'll start with the first piece, which is from 0 to 4. And here we have to pay attention to the wording again. We want to know where f is increasing at its greatest rate. So really what the question is asking us is for the absolute maximum of f prime of x, because f prime of x is the rate. And actually, let me be more careful here. They're really asking us for the absolute value of f prime of t. Remember, to find extrema, what we do is take the derivative of the function, set it equal to 0. In this case, we'll do the same thing, keeping in mind that the function which we need to take a derivative of is f prime. Also, we need to keep in mind here that for this interval in specific, from 0 to 4, our function f of t is defined as f of t is equal to negative 1 over 4 t cubed plus 3 over 2 t squared plus 1. Again, what we want to do is take the derivative of f prime of t and set that equal to 0, meaning we'll first take the derivative of f of t. So f prime of t is equal to, we'll use the power rule here, so remember, pop the power to the front. So that's negative 3 over 4. Bring the power down by 1, or subtract 1 from the power, so negative 3 over 4 t squared plus, once again, bring the power to the front. That's 2 times 3 over 2. The 2's are going to cancel there. T to the power of 1, which we can rewrite as negative 3 over 4 t squared plus 3t. Once again, this is the function that we want to know where its absolute max is. So we need to take its derivative. Now we're looking for f double prime of t, which would be the derivative of this function. Bring the power to the front once more, so 2 times negative 3 over 4 times t plus 3. And we'll simplify this, which gives us negative 3 over 2t plus 3. Now what we want to do is look for our critical values. So we want to set f double prime of t equal to 0, which means we have negative 3 over 2t plus 3 equals 0, which gives us t equals negative 3 times negative 2 over 3. The negative 3's cancel and we're left with t equals 2. So that's one value we got from this section. However, remember, they asked us to look at the places where f is increasing and determine the absolute max there. We have two intervals, the other one being from 12 to 16, so that's what we'll check next. And since they're asking us for an absolute maximum, although a bit indirectly, right, because they asked for the greatest rate, but that's really the absolute maximum. So we know that at some point we'll have to plug in our critical values into the function, into f prime of t. I'll make a list up here, and so far we have that t equals 2. That's one of the values that we have to check. I would also like to point out here that since t equals 2 is our only critical value between 0 and 4, it is also our absolute extrema in this interval, so we would not need to check the endpoints f prime of 0 and f prime of 4. The second interval that we need to look for is between 12 and 16. And if we notice on our graph, between 12 and 16, we have a linear piece of graph, which means that f prime of t, the derivative, will give us a constant. So the rate of change of f prime of t throughout that interval will always be the same. So for that piece of interval, f prime of t is changing at a constant rate. It is increasing at a constant rate, and we can find that rate by finding the slope of that little piece of graph. So f prime of t would be, we can use our slope formula using these 2 points, 16, 15 and 12, 9. We'll subtract the y values, so we have 15 minus 9 in the numerator over 16 minus 12 in the denominator, which gives us 6 over 4, which is 3 over 2. We did not necessarily get a critical value here. Instead, we got the actual rate of change of f prime. And over here in the little list that we're keeping track of, we can add that for t between 12 and 16, f prime of t is 3 over 2. Now, basically, what we have to do is compare 3 over 2 with f prime of 2 and see which one is greater. So if we remember, f prime of t is equal to negative 3 over 4 t squared plus 3t. We're interested in f prime of 2, and we get negative 3 over 4 times 4 plus 3 times 4, which is 12. Here the 4's cancel, we get negative 3 plus 12, which is 9. And now we can compare. The two numbers that we're comparing are the rate of change of f prime at 2, which we got 9, and the rate of change of f prime between 12 and 16, which was a constant value. Remember, we got 3 over 2. Clearly 9 is greater than 3 over 2, so our absolute maximum is happening when t equals 2. We'll finish up our answer by saying f is increasing at its greatest rate when t equals 2. Now, notice how the question was phrased. They said, at what time t is f increasing at its greatest rate? So this is enough to answer the question. However, if you want to be safe, just so you don't have to wonder about whether they're asking you for an x value or a y value, right? A t value or an f value in this case, you can also write your answer as f is increasing at its greatest rate when f prime of 2 is equal to 9. So this would be our final answer. Now, this question is very tricky because of the wording. And notice what they asked us is, at what time t is f increasing at its greatest rate? So the fact that f is increasing told us that we needed to focus our eyes on these intervals alone. So we looked at where f is increasing in the graph. And the fact that they're asking for its greatest rate, they're asking us for the absolute maximum of its rate. So they're asking us for the absolute maximum of f prime of t. And again, it's because of how the question is phrased. That was a really, really good one. Let's keep going. On to letter C. Letter C says, find the total number of calories burned over the time interval from 6 to 18. So they're asking for the total number of calories. And here again, we have to remember that what they gave us is a derivative. This is a rate. And if you're giving the rate of calories per minute, to find the total of calories, what you have to do is integrate. This is a very classic free response question where you're given a derivative, you're given the graph of a derivative, and you're asked about the total values of whatever they're talking about. In this case, it's calories. So that lets you know that what we need to do is integrate. And in this case, we're integrating from 6 to 18. If we zoom in on our graph here, from 6 to 18, 6 would be somewhere here, 18 would be somewhere here. And we need to figure out what shapes are making up this area. Notice that they're asking about an area under the graph that is linear. Okay, so they're doing this on purpose because you can rely on geometry formulas that you're pretty much used to since elementary school. One shape we can see here is a rectangle. Another shape we can see here is a trapezoid. And the third shape we can see in there is another little rectangle. Okay, so we'll rely on our geometric formulas to find these areas. And I'll start writing our setup right now. So the total number of calories from 6 to 18 would be the integral from 6 to 18 of f of t dt, which we'll find this geometrically again by considering the areas under the curve. Let me call them something. So this will be 1, 2, and 3. So that first area, the blue area in the graph, we'll need to consider the area of a rectangle. That's length times width, or base times height. If we notice, our base in this case is from 6 to 12. So we need to figure out what that length is. We do that by subtracting. So 12 minus 6, that gives us 6. The base of that rectangle is 6 units. And we need to multiply that times the height. The height would be the y value of 9. Notice at the top here is a horizontal line. They told us that the y value is 9. So we're multiplying 6 times 9 to get that piece of area. The next piece that we'll look at is a trapezoid, that yellow area right there. So remember, the area of a trapezoid is 1/2 base 1 plus base 2 times the height. If your trapezoid looks like this, where this is B1, this is B2, and the height is this distance here. What's important about a trapezoid is that the bases are the sides of the trapezoid that are parallel to each other. In this case, with our trapezoid, the sides that are parallel to each other are these. So that would be our base, meaning this distance here from 12 to 16 would be our height. So putting that into our formula, we have 1/2 times base 1 plus base 2. Well, those would be the y values. The y value here at this point is 9, plus the y value here at this point is 15. And we multiply that times the height of the trapezoid, which again in this case is really the difference between 16 and 12, which is 4. We have one more piece of area to consider, which is part 3 there, that green little rectangle. And for that rectangle, remember we're multiplying the base times the height to find the area. So we have the base, which is from 16 to 18. Okay, we subtract that and we get 2. So we have 2 times the height. The height in this case would be the y value here, which is 15. Now here I would like to emphasize that for the free response questions, they always encourage you to not simplify your answer. So this would technically be enough. However, we will need this value in the next question. So I'm going to go ahead and simplify it all the way through. So 6 times 9, that's 54. Over here, the 2 and the 4 will cancel, or simplify rather. So we have plus 9 plus 15, that's 24, times 2 plus 30. So we have 54 plus 48 plus 30, which when you add them all up, we get 132. Moving on to our next question, part D. This is the final part of number 4. It says the setting on the machine is now changed so that the person burns f of t plus c calories per minute. For this setting, find c so that an average of 15 calories per minute is burned during the time interval from 6 to 18. They're saying that they want the average to be 15 per minute, and we need to find the c. That's our unknown. So the question is c equals what? So they use the word average here. So what we need to remember here is the formula for average value. And the average value between an interval from A to B is given by 1 over b minus a times the integral from a to b of our function, whatever function it is that we want to find the average value of. So that's the formula we need to use for our question, and let's bring it back into the function that they're asking us about in specific, and they're asking us to find the average value of f of t plus c from 6 to 18. So we have 1 over b minus a, in this case 18 minus 6, times the integral from 6 to 18 of the function that we're talking about, which in this case is f of t plus c. Also remember your dt because they will deduct points for empty integrals. And the way the question is phrased, they're telling us that this average is 15, where our goal is to find c. So let's begin. We have 1 over 18 minus 6, that's 1 over 12, times the integral from 6 to 18 of f of t plus c dt equals 15. I'm going to cancel that coefficient of 1 over 12 by multiplying both sides by 12. So we get the integral from 6 to 18 of f of t plus c dt is equal to 15 times 12, which gives us 180. Now here we'll use our properties of integrals where we can split sums and differences, right? In this case, we're going to split the sum. So we have the integral from 6 to 18 of f of t dt plus the integral from 6 to 18 of c dt is equal to 180. And this is what I was talking about earlier. If you notice, this is exactly what they asked us to find in the previous section in part C. And we found that it was 132. So our equation becomes 132 plus the integral from 6 to 18 of c dt is equal to 180. And that gives us that the integral from 6 to 18 of c dt is equal to 180 minus 132, which is 48. Now, this is not enough to say that we found our value for c. We do need to integrate the left side. However, notice c is just a constant, it's just a number. So when we take the integral of just a number, we attach our variable to it. In this case, our variable is t. So the left side gives us c times t from 18 to 6 equals 48. That means that we plug in 18 and we plug in 6 in that order. So we have 18c minus 6c is equal to 48, which means 12c equals 48. Which means c equals 4. And we answered the question. That was a tricky one. I hope you found this video helpful, guys. Enjoy the rest of your day.